Good morning, ladies and gentlemen. Sorry I could not be here again today. Again, family emergency. I apologize for that. We are going to carry on as much as normal here, please. So the first thing we are going to do is warm-up number 6. So if you could take out your green warm-up sheets, please. Also, if someone in class would be kind enough to pass out the calculators, that would be great. I will pause for about a minute so everybody can get situated. All right, we're going to go ahead and get started here. Let's look at the agenda. All right, so warm-up number 6, lesson 2.1, representing relationships and functions. We're going to take some notes. I will go over that, so take notes very carefully. And again, the notes will also be on Moodle. Chapter 2 assignment sheet, you will get that. That assignment sheet is yellow. And then you're going to get a worksheet that is blue, and you can work on that. Looking at the bottom, looking ahead notes, I am hoping to have your test graded by Friday. Okay, as of right now when I recorded this, I have not started yet, but it is my goal to have them graded by Friday. If you have things to hand in, please put your assignments in the day 1, period 2 basket by the windows. Make sure you get it in the right basket, please. There's a stapler on top of my desk, or not on top of my desk, on top of my filing cabinet if you need to staple things together. Okay, so please get those worksheets, book assignments, get those turned in. All right, let us begin with the warm-up. All right, I know this was from chapter 1. This is a warm-up we missed last week, so we're going to go ahead and do this warm-up now. So we're going to determine all values of p that satisfy the equation. All right, so the absolute value of 6 minus p equals 4. All right, so remember we're going to create 2 equations with that. And then the other equation would be 6 minus p equals negative 4. All right, solve both of them. Remember, you cannot stop with a negative variable, so you need to get rid of the negative. So one solution is 2. Same thing, you cannot stop with a negative variable. And so the second solution is 10. All right, so make sure you have both of those on your warm-up sheet. I'll leave that up there for approximately 30 to 40 seconds. One thing I forgot to mention is that you should check these. You can pretty much do that in your head, I would think. 6 minus 2 is 4, and the absolute value of 4 is 4, so that one checks. and 6 minus 10 would be negative 4, and the absolute value of negative 4 is 4, so that checks. Okay, don't forget to check because sometimes you may have extraneous solutions. All right, we are going to move on to notes next, so go ahead, put your warm-up away and take out your notebook. Sorry, that's the wrong notes. There we go. All right, so I'm going to pause for approximately a minute and a half, 2 minutes. Go ahead and write those things down, and then I'm going to talk about a few things. Nothing like having your email flash up in the corner when you're recording. All right, hopefully you managed to get quite a bit of that down. So we are looking at relations and functions today. First of all, we have a mapping. You can see the mapping on the right where we have some arrows drawn from one number to another number. Okay, the column on the left, those are considered the input values. And the column on the right, those are the output values. Also, the input values, remember those are the x values, and the output values are the y values. Okay, and the other three ways that we can look at relations is with ordered pairs. Okay, remember ordered pairs are x, y. We can represent them with a table. Or we can also represent it with a graph by plotting each of the points. That is still considered a relation. Okay, so those are 4 ways to represent a relation. Okay, we're going to move on. So let's review domain and range. Okay, remember the domain, also known as your input, that is your x values. The range is your output, and those are your y values. Okay, I'll give you a minute to go ahead and copy the rest of this page. All right, we're going to move on. Again, if you did not get that, I apologize. You can either find someone in the room that got it copied, or you can go check it on Moodle. Okay, next page. All right, we're going to get more specific now. So far, it's just generally a relation. What is a relation? But now we're going to be more specific. A function. Okay, a function is a relation for which each input has exactly one output. So each x value has exactly one y value. All right, so let's take a look at these two examples. All right, so I'm going to write this out. So I've got my input and I've got my output. All right, so here we go. Starting with the first one. I'm going to write this out and then I'll pause so you can finish copying it. Here we go. So the -2 has one output, -1. Okay. -1 has one output, and that would be 0. 3 has one output, and that would be 0. 6 has one output, and that would be 4. So each input has one output. Therefore, it is a function. Okay. Looking at the next one, I'm going to do the same thing. -2 has one output, -2. 1 has one output. That would be 0. 2 has two outputs, 2 and 3. Uh-oh. That is not what a function is. Okay? Again, a function can only have one output. So, this is not a function. Okay, I'm going to pause for approximately 1 minute so that you can finish copying. While I'm thinking of it, ladies and gentlemen, we were going to do retakes on mastery quizzes today. Obviously, we are not going to do that. I apologize highly for that. We shall work on those on Friday. I should be here on Friday, I hope. All right, moving on. All right, the vertical line test. A relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. Okay, so I am going to create a vertical line and I am going to move it around so that you can see how this works. I think you pretty much can figure it out, but I'm going to go ahead and pull up a vertical line. Okay, so I have my vertical line. Let me get back to this. All right, here's my vertical line. Okay, so you take a vertical line. It can be a pen or a pencil or whatever, a ruler if you have one. And you can take your vertical line and you can put it on the graph. Okay, so I put it on the graph here. I see it's only touching in one spot. Vertical line here, one spot, one spot, one spot. Anywhere that I place this vertical line, it is touching only in one spot. Therefore, this is a function. Okay, pretty easy to see when we go over here. Isn't that magic with the line disappearing there? We go over here and we can see when I do the vertical line, it's touching in two spots. Okay, it's touching right here and it's touching right here. That tells me it is not a function. That's telling me that there is an input with two outputs. Okay, so that's the vertical line test. All right, I will pause for about 20 seconds and then we'll continue. All right, we're going to continue. Okay, a couple slides left. All right, equation in two variables. Okay, we've already solved equations with one variable, but now we're doing the two variables, and we did a little bit with the two variables before. Okay, an equation that has an independent or input variable. Okay, remember that's your x value. And a dependent or output variable. That would be your y. That depends on the value of the input variable. Okay, we did a little bit of that when we solved for y in the first chapter. So a function that can be written in the form y equals mx plus b, where m and b are constants. All right, so what we need to remember here is this is the slope intercept form. M, remember, is your slope. And that's rise over run. Also, we can look at it this way. Vertical change over horizontal change. Okay? Now remember, the word constant means it's a number that does not change. In an equation, the slope and the b are constants. Those are numbers that do not change for that equation. Okay, now the b, when we are graphing it, remember that is considered the starting point. Okay, we call that the y-intercept. Hence, slope-intercept form. Okay, I'll leave that up there for about 40 seconds. All right, let's continue, please. All right, so graphing equations. Okay, you've done this before. So step one, it says construct a table of values. Okay, well, you can draw a graph without having to construct a table of values. Okay, but I'm just going to go through making that table and then going ahead and plotting some of the points, because this goes along with input output, just getting that connection. So we've got this table right here, x, y. Okay, I'm going to go ahead and I like using 0, so I'm going to put 0 in there. So now remember, that 0 is our input. So -2 times 0 minus 2, we're going to get an output of -2. Okay, that is also known as our y-intercept, 0, -2. So that is our starting point. Now, you could use the slope to create the other dots, but I'm just going to go ahead and put some more input in. So I'm going to go ahead and make life easy. I'm just going to use 1. So I got -2 times 1 minus 2, and that's going to give us -4. So 1, -4. Okay, I'm going to go ahead and use 2. -2 times 2 minus 2 equals -6. So input of 2, output of -6. Okay, I'm going to go ahead and do another one. This time I'm going to go ahead and pick a negative. And again, I'm going to make life easy. I'm just going to use -1. So -2 times -1 minus 2. That would be +2 minus 2, which is 0. So -1, 0. Now again, this is your slope. This is your y-intercept. Okay, and if I look, my y-intercept, yep, it's right there at -2. My slope is down 2, remember rise over run, down 2 over 1, down 2 over 1. Okay, don't forget, draw your line through the dots, all the way through the graph. You'll have to do yours freehand, and don't forget to put arrows on it. Okay, I'm going to pause for 1 minute, and then I'm going to wrap this up with one more problem that you're going to see in your assignments. Okay, last thing. Now, please remember, about 5 minutes before the end of class, all calculators need to be collected and put away. All right, and then I will see you on Friday. So after the notes, then you will receive the worksheet for this section. I would like you to have it completed on Friday and turn it in on Friday, and then you're going to get your book assignment sheet and you can start working on that stuff. Everything's up on Moodle and ready to roll. All right, let's finish this. Okay, so you're going to see a problem like this. You should know what to do, but I'm going to just go over it anyway. So f of x, now remember f of x means function of x. That's like the y equals. So f of x equals 2x squared minus 6. And then you're going to see a semicolon, and then it's going to say find f like -3. Okay, simple. It's just plug it in to the function and find what it equals. It's an input and an output. So we're going to plug in the -3 for x. Remember, we do order of operations. So the exponent would be first. -3 squared is 9. Okay, then 2 times 9 is 18, minus 6, and we get an output value of 12. So f of -3 equals 12. If I were to write that as an ordered pair, it would be -3, 12. Input, output. All right. Have a good day. See you on Friday.